Hello, everybody. So today we're going to begin our discussion in Chapter 8, Section 2, and it's a little bit of a continuation of the exponent rules that we just got done discussing, but it's more of an application of those exponent rules. One of the things that we'll be doing as you progress through your various math courses is you'll be dealing with larger what are called algebraic expressions. And you need to know how to manipulate those algebraic expressions in order to condense them down into their simplest form possible. So that's what we're going to begin to talk about today. So what I'm going to show you is how to multiply a polynomial by a monomial. Now, if you recall, the word poly is the prefix poly of polynomial means many terms. So this right here, anytime we get to really three terms or more, we begin to call those polynomials, although the word polynomial can apply to pretty much any algebraic expression. And we're going to multiply that polynomial by this monomial right here, this negative 3x squared. So what is going to happen is this negative 3x squared is going to distribute to the 7x squared, to the negative x, and to the positive 4. So we have to begin to multiply those across. We start by multiplying the constant coefficient, in this case, negative 3 times 7, which gives us negative 21. Then we have x squared times x squared. So if you recall, when we have x squared times x squared, we add the exponents and it becomes x to the 4th. So what I just did is I just took negative 3x squared and I multiplied it by 7x squared. Now I'm going to take that same negative 3x squared and I'm going to multiply it by negative x. So negative 3 times negative 1 is positive 3. Then we have x squared times x. And there again, we have x squared times x to the 1st. So we add the exponents and we get x to the 3rd power. Now, the last distributive part that we're going to do is going to be the it's going to be the negative 3x squared times positive 4. So negative 3x squared times positive 4 is going to be negative 12. And then you need to include the x squared. So what we have now is a completed distributed monomial, and we end up with negative 21 x to the 4th plus 3x to the 3rd minus 12x squared. Here's another one we're going to try. Same idea as the last one. We're going to take this 5a squared and distribute it to each of the terms in the second polynomial. So we're going to start with 5a squared times negative 4a squared. 5 times negative 4 is negative 20. And then a squared times a squared, we add the exponents, it becomes a to the 4th power. The next part is we're taking 5a squared and we are multiplying the 2a. So 5 times 2 is 10, and then we have a squared times a to the 1st, which becomes a to the 3rd. So remember, a squared times a squared is a to the 4th. Then we have a squared times a to the 1st. That becomes a to the 3rd. The last distributive property we're going to do is this 5a squared times negative 7. So 5a squared times negative 7 is negative 35, and then the a squared doesn't have anything to multiply with, so it just kind of comes along for the ride there. And there's our final answer, negative 20, a to the 4th, plus 10a to the 3rd, minus 35a squared. I have one more of these types to show you. And same idea as the last two. We're going to take that negative 6d to the 3rd and we're going to distribute it to each of the terms. And it doesn't matter how many terms are inside the parentheses, each one has to get multiplied by that single monomial on the outside. So in this case, negative 6d to the third is going to distribute it to each one of those. So I'm going to erase that. So we have negative 6 times 3, which is negative 18. And then we have d to the third times d to the fourth, which gives us d to the seventh. Remember, the powers add. The next one, we're going to distribute this to the second term in that polynomial. So negative 6 times negative 2 is positive 12. And then d to the third times d to the third will become d to the sixth power, because we are adding 3 plus 3. The next one, we distribute negative 6d to the third times negative 1d to the first. This one's a little tricky. Negative 6 times negative 1 is positive 6. And then we have d to the third times d to the first. That gives us d to the fourth power. So we're left with 6d to the fourth. Then the last step here is the negative 6d to the third times positive 9. And so you have a negative times a positive, which is a negative. And 6 times 9 is 54. And then the d to the third just gets written down because there's nothing over here for it to multiply with. So there's our final answer, negative 18d to the seventh plus 12d to the sixth plus 6d to the fourth minus 54d to the third power. So now what I'm going to move on to is to show you how to simplify a little bit more complicated expressions. And what makes this more complicated is you can see that there are two different terms that need to be distributed. So this is kind of like two of the previous problems that we did in one. But then the additional part of that is the like terms are going to need to be combined together. So let's try it. So this 2p right here is distributing to the negative 4p squared and the 5p. But then we have a second distributive problem. This negative 5 has to distribute to the 2p squared and the 20, like that. So we have two different distributive properties that need to be done before we can begin to actually kind of condense this problem down. So we have 2p times negative 4p squared. So we're going to start with this one, 2p times negative 4p squared. So 2 times negative 4 is negative 8, and then p to the first times p to the second becomes p to the third. Next, we have 2p times positive 5p. That will give us 10p to the second. Remember, p to the first times p to the first becomes p to the second. So now that we've distributed that first 2p, we can now distribute this negative 5, and it gets distributed to both of the terms after it. So negative 5 times 2p squared becomes negative 10p squared. Negative 5 times 2 is negative 10, and then p squared. Then the last distributive property we're going to do there is the negative 5 times 20, which becomes negative 100, just like that. Now, looking at our expression, we have completely distributed all the monomials, but now we need to look over the expression and determine whether there is any like terms that could be combined. And looking at this, we have 10p squared and negative 10p squared. Those two terms are the same because they have the same variable and they have the same power. So because they have the same variable and the same power, they can be combined. 10 minus 10 is 0. So what ends up happening is these two cancel out because they're opposites of one another. And we're just left with negative 8p to the third minus 100. And there's your final answer. So we took something that was pretty messy, expanded a little bit more, and then condensed it down by combining all of our like terms, and we ended up with a much simpler algebraic expression. So the last one I'm going to show you today is this one. It's very similar to the last one. The only difference is that there's 3 terms in each of the polynomials here that you're going to be distributing to. So this 3 gets distributed to all 3 terms, and then this negative x gets distributed to all 3 terms, just like that. So that's what we need to do. So let's get started here. The first one we're doing is 3 times 5x squared. That gives me 15x squared. Followed by that, we multiply 3 times 2x, which gives me 6x. And then 3 times negative 4, which is negative 12. From there, we distribute the negative x. Negative x times 7x squared. So negative 1 times positive 7 is negative 7x to the third. Again, remember, x to the first times x to the second gives me x to the third. Then we distribute the negative x to the 2x. So negative 1x times 2x gives me negative 2x to the second. X to the first times x to the first is x to the second. The last distributive property we're doing is the negative x times negative 3, which gives me positive 3x. Now, looking over our expression, we need to find if there are any like terms, and if there are like terms, we need to combine them. So I'm going to go through and I'm going to highlight the like terms. We can see that we have an x squared term right here, and then we have an x squared term right there. So those two will need to be combined together. The next one I see is we have a positive 6x right there, and then we have a positive 3x right there. So those two are like terms. So those two will need to be combined as well. Now, in order to properly write your final answer, and I probably should have said this earlier, you need to make sure that your variables are in order from the highest power to the lowest. So looking over this expression, the highest power variable that we have right here is this negative 7x to the third. So that is the first term we write, negative 7x to the third. Followed by that, we have x squared. And what we have here is 15x squared minus 2x squared. So if I do 15 minus 2, I end up with 13, positive 13x squared. Now, followed by the x squared, we would go to the x terms. In this case, we have a 6x and a 3x. They're both positive. So when we add 6x and 3x, we get 9x. And then the last term is this minus 12 right here. We don't want to forget about that, minus 12. And there you go. That is your final answer, negative 7x to the third plus 13x squared plus 9x minus 12. So I hope that made sense to you. As always, if you have any questions, feel free to email me. Have a great day.